Hello, good morning. I'm Mrs. Macer. Again, your teacher in Earth Science. We are now proceeding with topic number 4, which is actually all about plate tectonics. But firstly, before we begin on the discussion proper of the mechanisms behind plate tectonics, movements on each plate boundaries, landforms formed on each boundary, we will now discuss first the history and some people behind and their contributions about plate tectonics. So to begin with, in the beginning of the 20th century, many scientists explained the physical attributes of Earth. Using the racine theory, according to this theory, Earth is like a grape that contracted into a racine due to cooling process that occurred on Earth after the Big Bang about 13.77 billion years ago. So they do believe that due to this cooling and then contraction effect, some solid parts of the Earth pertaining to the continental crust buckled up and formed mountains and other topographical features found on continental, both on continental and then oceanic crust. Because we do know that both of these crusts are actually having these topographical features. So during this period, they do believe that the cooling process, together with this cooling process, some parts of our land buckled up and leads to the formation of these mountains, hills, plateaus, and other landforms formation here on Earth. They thought that the cooling caused a contraction and pressure that allowed some parts of the crust to move upwards, as I've said a while ago, and produce mountains, while the other parts of the crust buckled downwards, creating ocean basins and other depressions. So just like if there is this upwarping process that occurred, there will be some downwarping processes that leads to formation of basins on the ocean floor. The contracting Earth concept was further explained when an American seismologist and geologist, Clarence Edward Dutton, proposed the isostasy theory. In 1889, the theory isostasy states that wherever equilibrium exists in Earth's surface, equal mass must be formed of lighter materials than that supposed to constitute the ocean floor. So which means all that is actually found on the topmost portion or found here on the topmost portion of the Earth's crust must be lighter than those found on the bottom part, specifically those on the Earth's interior. So as you go deeper, as pertaining to this isostasy theory, those that are actually at the bottom or on the Earth's interior must be heavier enough to support those landforms formed on the topmost portion of the Earth. Tectonic is a term derived from a Greek word tecton, which means carpenter or builder. Tectonic plates has been used by scientists to describe the movement of the lithosphere. However, this term is now widely used for describing the physical plates rather than their movement. Because nowadays, lithosphere is described as that part of the Earth, Earth's a solid part which is actually subdivided or fragmented into parts, into huge parts, sometimes into smaller parts, leading to formation of huge continents and some islands and islets. Tectonic plates, also called lithospheric plates, as we do know nowadays, are massive irregular slabs of solid rock that envelope the surface of the Earth. Again, this slabs of rock are fragmented irregularly. They are not by shape. Is actually in regular form. No? So they are actually fragmented into different shapes, size, and form. So the theory of plate tectonics states that the Earth's outermost layer is fragmented into a dozen or more large and solid plates or slabs called lithospheric or tectonic plates. So as shown on the picture, as you can see, the lithosphere is subdivided into huge continents that we have today. Some are actually really huge, such as the North American plate and then the South American plate. But some are actually small, such as the Indian plate, the Philippine Sea plate, the Cocos plate, and then the Caribbean plate. Actually, there are a lot more plates we'll be discussing as we proceed to our discussion. Which are actually, these lithospheric plates are actually in constant motion relatively to one another. So, when one plate moved or collide with other plates, there is this one plate which is denser that will go down or subduct or submerge, while the other plate will move on top of the submerged plate. And this particular motion, this particular process that occurs on our Earth's interior, to be specific on our lithospheric plates, when this occurs, a lot of things or a lot of landforms might form, or sometimes some earthquake occurrences might occur on this type of movement of plates with respect to one another. The theory of plate tectonics states that the Earth's outermost layer, which is actually the lithosphere, is fragmented into dozen or more large and small solid plates or slabs called lithospheric plates. These plates are fit together like the pieces of a jigsaw puzzle, and the movement ranges from less than 1 to 15 centimeter per year. It depends upon the movement of each plate. Like for example, the Pacific plate, which is considered to be the biggest plate amongst the huge slabs of lithospheric plates, with its size comes with its activity. It's the most active plate. So apart from being the biggest, it is also the most active plate. So when this Pacific plate move, all the surrounding plates that surrounds this Pacific plate is actually greatly affected from its movement. So sometimes it would lead to landform formation or additional landforms such as mountain, volcanoes. Don't worry, I will discuss that one by one. Sometimes earthquakes might occur on that particular movement. But then again, may I reiterate on this, as one plate move, it will have an effect to the other plate. Thus, this plate tectonics is actually their motion is actually relative to one another. As one plate move, the other plate will likewise move. Okay? The motion of the plates over millions of years resulted in the openings. This is just one of the effects. Opening and closure of bodies of water, likewise the formation and disintegration of continents in the world. Don't worry, as we proceed to our discussion, I will discuss how some regions of the earth are being removed or totally deleted on the world map, and how some parts of the earth are being added up. So there will be an addition to the crust, and sometimes there are some parts of the crust which are actually being removed. No? So don't worry, I will discuss that one at a time. The plate tectonics theory was developed from earlier hypotheses and data collected about the rocks of the ocean floor. Okay, so that's one of the evidences. Even the evidences, we will have a separate discussion on that because that is a very huge, one of the huge topic here on grade 10. One of the foundational works that gave rise to this theory is the First World Atlas, the Theatrum Orbis Terrarum, which was developed and published by Abraham Ortelius on May 20, 1570. But as you can see from its from the work of Abraham Ortelius, some parts of the Earth is not yet discovered during that time. So, which means from that period, which is actually 15th century, early period of the 15th century, some parts of the world is not yet discovered by Sir Abraham Ortelius. Or we could also say that there are some parts of the Earth which are not yet fully developed or formed yet. So they are not yet formed. That is why they are not yet part of the First World Atlas made by Abraham Ortelius. Ortelius noted the similarity between the coastlines of Africa, Europe, and the Americas, and adapted Plato's story of the Demis of Atlantis. He suggested that America was originally connected to Europe and Africa, and that the projecting parts of the two continents would fit the recesses of America. So, based from the observation of Abraham Ortelius, these four major continents such as North and South America, Europe, and Africa were once connected. But again, he was not able to give a more specified justifications on his let's say statement, not conclusion yet. It's just that there was no enough evidence with that statement of Abraham Ortelius. That was just only his observation. Ortelius' hypothesis remained silent for several centuries until an Austrian climatologist. So what do you mean by climatologist? This is with respect to the study of the changes on our weather and climate. So Alfred Wegener proposed the Continental Drift Theory. Don't worry, we will have a separate, because again, this Continental Drift Theory is one which is actually a proponent that were used by some scientists who formulated the plate tectonics theory to really formulate and develop the plate tectonics theory. They use this continental drift theory of Alfred Wegener. Okay? In his book, The Origins of Continents and Oceans in 1915, Wegener expanded his theory and presented evidences that Pangaea, meaning all Earth, had really existed during the Permian period. So, when we speak of Pangaea or all Earth, these land masses that we have today that were actually separated by water, huge oceans, and seas were once connected as a single landmass called Pangaea. So that was actually the theory behind this continental drift theory. So as you can see on the picture, don't worry, we'll have a separate discussion on this. The land masses, continents that we have today were once connected as a single landmass called Pangaea, as shown or as per evidences show on this figure. There are some traces of animals such as this Mesosaurus, and this Mesosaurus is actually a very huge type of animal or reptile per se, which can live both on water and on land. But the case is that its traces is found both on South America and Africa. But then again, Dory will have a very thorough discussion on this. From the current position of these two major continents, which are actually South America and Africa, it would be very impossible for this huge reptile to travel from one continent, which is actually South America, going to Africa, because they are separated by the second largest ocean in the world, which is actually the Atlantic Ocean, with no traces of islands or islets in between South America and Africa. Alfred Wegener questioned the reality behind how this particular reptile could travel from South America to Africa with no period of resting at all. So it would be very hard for this particular animal to travel through these two separated huge continents. So he proposed that might be on the historical period of the Earth, wherein it is actually on its developing form, these huge land masses that we have today, or the continents that we have today, were really once connected as a single land mass called Pangaea. So this is actually a trace or a fossil of a Mesosaurus, as shown on the picture. And these are some of the animals that were found on different continents, specifically in the case of Lystrosaurus, the Lystrosaurus, traces of which are actually found on Antarctica, which is actually on the bottom part of the Earth, then India, and likewise it is found on Africa. So these two, if you're going to look on the current positions of this Africa, Antarctica, and India, these are actually separated really away from each other. So how come that this huge type of animal, which is actually Lystrosaurus, could travel from one continent to the next if and ever they are not connected once in the history of the developing Earth? So these were just the holding evidences, firm evidences of Alfred Wegener that really once in the history of the Earth or of the developing Earth, these land masses were once connected as a single land mass. Next would be some plants like Glossopteris, which are actually found on fossils of the fern Glossopteris found in all of the southern continents. So what are those southern continents? Australia, Antarctica, Africa, and then South America. Again, during this period, this current time, the positions of the southern continents, such as Australia, Antarctica, India, Africa, and then South America, they are really away from each other. To be specific, they are really separated by huge bodies of water. So that's a very, very question on the part of Alfred Wegener, because Glossopteris is a plant. So how come that there will be some traces of this particular plant on Antarctica, which is actually considered as a cold region? So that would be a very hard question to answer, because on a cold region, it would be very hard to plant a tree, or to be specific, a fern. So that's a very firm evidence on the part of Alfred Wegener that really once in the history of the Earth, these land masses or continents were once connected as a single landmass. When Jenner explained that about 1,100 million years ago, there was a supercontinent named Rodinia. So this Rodinia predated Pangaea. Okay? So 1,100 million years ago, there was a supercontinent named Rodinia which predated, may I reiterate on that, predated Pangaea. Now, during the late Triassic period, Pangaea began to break up into two smaller continents called Laurasia. Because may I reiterate on this, tectonics or plate tectonics or these huge slabs of rocks are really active. They are actually moving relative to one another, and they are actually in constant motion, and an average of 1 to 15 centimeter per year or more. Okay? Now, it depends on the activity of that particular slab of rock or lithospheric plate. Now, these two separated plates or continents from Pangaea were named as Laurasia and Gondwanaland. Gondwanaland, which moved to the northern, while Laurasia moved to the northern extremes of the planet, while Gondwanaland moved to the southern extremes of the planet. Starting at about 514 million years ago, Laurasia drifted southward until it crashed into Gondwanaland about 425 million years ago. So this Laurasia moved downward and then bumped into Gondwanaland. Now, as an effect of this, Pantalasa, a vast ocean surrounding the Pangaea, was formed at about approximately 356 million years ago. While the two continents were separated by Tethys C 251 to 65.5 million years ago. So together with this this bumping or movement of Laurasia downward, it created a new sea from Pantalasa to Tethys. The Tethys Sea now separates the upper extremes, which is actually Laurasia, and then Gondwanaland. Now, in between them is actually a huge body of water, which is actually the Tethys Sea. Tethys Sea is just an effect of the movement or of the separation of Laurasia and then Gondwanaland. Now, this picture shows the movement of the Earth from the first period of movement to its current position. Now, 200, may I just discuss this one? 200 million years ago, as shown on the picture above, Pangaea was formed. And then, but before that, there was the supercontinent Rodinia, which predated Pangaea. Now, with this type of formation, you have Pangaea. And then after that, 135 million years ago, Laurasia, the Pangaea separated into two, which forms Laurasia on the uppermost part and Gondwanaland on the lowermost part. Now, the separation created a huge body of water in between them, which is actually the Tethys Sea. But before that, before we have the Tethys Sea, we have the all oceans. If we have the all land with respect to Pangaea, we also have the all oceans referring to Pantalasa. Now, 65 million years ago, the movement of this Laurasia and Gondwanaland continues. And as you can see, each continent moved away from each other. Some move on the northern part, going to the northern part. Some move downwards, such as the Antarctica, and then Australia. And then some parts move westwards, such as the North and then South American plate. Okay? And then, as of today, this is the current position, but again, may reiterate on this. This plates that we have today, or the contents that we have today, are still in continuous motion. Okay? Next. During the history of Pangaea's formation, the now known North America smashed into northwestern Africa, forming a vast mountain range. Traces of these mountain ranges can still be located on the belt stretching from the South United States to northern Europe, including the Appalachians. So this smashing of the North America into Africa created this Appalachian mountain ranges. Rock traces from the edges of these two continents, the North America and then the Africa, shows proof that they matches together. So with this proof, they concluded, to be specific, Alfred Wegener concluded that once in the history of the developing Earth, North America is actually connected to Africa because of these traces of rocks. Okay, as Pangaea continued northward and crashed into the ocean floor of Pantalasa, it created a chain of mountain ranges extending from Alaska to southern South America. At around 200 million years ago, Pangaea began to break apart, forming a valley that is now known called Atlantic Ocean. Because this Pangaea continued to smash the Pantalasa ocean floor. Okay, now to this effect, it created the Atlantic Ocean. So, if you're going to look on the current condition of Atlantic Ocean, you will see parts of it that is actually containing mountains or series of mountains on the ocean floor. Though that is actually a trace of this smashing effect of the Pangaea against Pantalasa. Continental drifting continues during the Jurassic period, and by the end of the Cretaceous period and the beginning of Cenozoic, the continents were already taking their forms as we now know them today. However, during those periods, the big land masses now known as Central America was still covered with water, while Antarctica and Australia had still not separated from this period, which to be specific, at the end of the Cretaceous and on the early Cenozoic. And then India was still covered with water, while the present continents and oceans had been formed. So during this period of early Cenozoic, most oceans are actually present because, as you can see on the figure, the continents are actually actively moving away from each other, leading to formation of oceans and bodies of water. Na just to have a brief recap, Tete Sea was formed from the separation of Pangaea into two, Laurasia and Gondwana. Now, from this movement in separation of different continents, there, in accord to that, there will be a formation likewise of a new bodies of water. Now, India was moving northward, eventually smashing into southern Asia. Such movement and plate interactions shaped the world's tallest mountain. This is actually, I discussed during the mountain range discussion or formation of the Himalayas mountain range. The Karakoram range and the Hindu Kush. Remember, these three mountain ranges were near to one another. Scientists believe that the crustal plates are still drifting. It is also predicted that some 250 to 300 million years from now, the seven continents will move towards each other, again reforming the historical Pangaea. Earth is generally composed of 58 crustal active plates. Okay, out of this plate, scientists have identified 15 major, again, 15 major tectonic, 7 or 8 of which are primary plates. This is actually represented by the 7 continents that we have today. The primary plates are actually the African, Eurasian, Indo-Australian, North American, Pacific, and the South American plate. Sometimes with the Nazca plate, considered as a primary plate instead as a secondary plate because the Nazca plate is so active. Now, apart from being so huge to be considered as a primary plate, since Nazca is so active, it is sometimes considered as a primary plate. The secondary plates are actually the Arabian plate, Caribbean plate, Cocos plate, Indian plate, Juan de Duca plate, Philippine Sea plate, Scotia plate, and sometimes the Nazca plate. Tertiary plates are smaller parts of primary or secondary plates that have broken off and continue being broken off over time. It can be noted that the primary plates comprise the majority of the land masses of the world's major continents along with most of the surface area of Earth's oceans. So that is actually the tertiary plates. So that's all for today. I hope you learned something new to my discussion for topic that we have for this school year. And I hope you do learn a lot from my discussion. If you have some questions, just do message me on Google Hangouts and through our Google Classroom. So that's all for today. Goodbye and thank you, class.